Hi, my name's Will Krawczyk, Scientific Services Manager at Chemical Computing Group. Today I'd like to demonstrate how to perform a Pharmacophore search. This is a useful workflow when we'd like to find new molecules based on their pharmacophoric features that would perhaps fit in a certain binding pocket or preserve a certain key interaction. So let's get started. The structure we'll be using today is EGFR kinase with a ligand called Tasiva which is bound. In the interest of time, I've already prepared this complex ready for interactive analysis, and I did that using Quick Prep, running the default settings. In order to generate a pharmacophore, we first need to analyze this complex to understand the important features. I'll start this analysis by looking in the main Mo window, and here I find that Mo has automatically calculated and annotated the classical hydrogen bonds. These are shown with the dotted line with the cylinder in the middle. These show me where I might want to generate a pharmacophore. The size of these cylinders are important. They give me an idea about the strength of the bond. The longer the cylinder, the stronger the bond. So let's create a pharmacophore to encode the strongest of the three bonds together with an aromatic center here. But before we do that, let's first assess the properties of our binding pocket. For that, I can generate a surface, and here you'll see some of the default surfaces. I'm going to generate a receptor surface, which by default is coloured by atom colour. However, I can project different properties onto this surface. As an example, I can colour the pocket by lipophilicity, which will allow me to identify the greasy hydrophobic regions of the pocket shown in green, relative to the polar regions shown in pink or in purple. Here I find that the canazoline core appears to sit in a hydrophobic region of the pocket, and if I just rotate our model around, I see the back of the pocket also appears to be hydrophobic. So we can create a hydrophobic feature here to ensure that we only see hydrophobic groups in this part of the pocket. At this stage we can say that our analysis of the complex is complete. So in the next steps, what we can do is define a pharmacophore to encode the strong H bond that we see here, together with the hydrophobic region of the pocket, and we can also specify a pocket volume to ensure the ligands we query can actually fit in that pocket. We can then use that pharmacophore query to search for ligands with similar pharmacophoric features from internal databases or perhaps vendor catalogues. For that, we're going to need our Pharmacophore Query Editor. The panel comprises three main sections. At the top, it allows for creating pharmacophore features from either the receptor or ligand atom sets. In the middle, we'll soon be listing our pharmacophore features, which are completely customizable. And at the bottom, this enables advanced search options, such as partial matches. If I just move that to one side, you'll notice that the main Mo window has been updated to show us the annotation points. We can use these to define our pharmacophore features. You'll notice that some of the annotation points don't sit directly on the ligand. They're projected features, and they give us an idea about directionality. So let's generate our first pharmacophore. That'll represent the aromatic center here for the scaffold. So I'm going to start by clicking on the orange aromatic center annotation point, and I'll go to the Pharmacophore Editor, hit Feature, and as simple as that, we've generated our first pharmacophore. Next, I'm going to encode this strong H bond. So I'm going to select the cyan annotation point, but I'm going to shift-click and select the projected annotation point also. I'll create features here, and we see those two acceptor features have been generated together with a constraint. This constraint specifies that both acceptor features must originate from the same atom. They can't be confused with another acceptor that happens to be pointing in a similar direction. This ensures that we find structures that have an acceptor that originate here and point out towards the receptor environment. Next, we're going to generate a pharmacophore to ensure that we only find ligands with hydrophobic features that fit in the hydrophobic region of the pocket. Here I find that we've got both a green hydrophobic annotation point, but also an orange aromatic annotation point. I'm going to shift-click to select them both, and click on Feature, and you'll see here that Mo has automatically created a Boolean operator, so that we find ligands with either a hydrophobic feature or an aromatic center. We can customize these Boolean operators with and or not operators, and I can also adjust the size of this feature should I wish. Finally, I'm going to want to ensure that the ligands actually fit within the binding pocket. If I just bring back our surface so that we can see the binding pocket. So what I'm going to do is create an excluded volume around the outside of the active site. So I'm going to do this by selecting our pocket atoms, and then I'm going to generate an excluded volume here. Let me just adjust our rendering to make that a little easier to see. And this ensures that the ligand atoms that we query do not enter this excluded volume around the outside of the pocket. Or in other words, they're going to be accommodated by the size and shape of the binding pocket. So next we're going to use the Pharmacophore features that we've generated here to find new ligands that happen to share these features. For that we're going to need Pharmacophore Search. The panel opens comprising three main sections. At the top we can specify the conformational database that we'd like to search. In the middle we can add filters, be those 2D descriptors or 3D Pharmacophore queries. The bottom allows us to control the search output. So here I'm going to start by specifying the conformational database that we'd like to query. I'll just select that, and it's important to note that the Pharmacophore Search application does not generate conformations on the fly. So here I selected a database where the conformations have been pre-generated. Moving down the panel, the middle part of the panel has automatically detected the Pharmacophore Query Editor, which is exactly what I want. So I'll move on to the next part of the panel to control the search output. Here, because we're using a conformational database, we can have multiple conformations per ligand. So I'm going to select the best conformation per molecule to be written to the output database. I'll click Search to initiate the search, and in the background Mo will now compare our Pharmacophore query to the Pharmacophore features associated with each of the ligands in the conformational database. Only the ligands which pass the Pharmacophore filter are considered hits and are written to the output database. So let's have a look at that output database. I'll just go ahead and open that up, and here we see it's displayed in the database viewer, which looks and feels much like an Excel spreadsheet, but you see it actually contains the 3D structure of our ligands. From here I could go ahead and calculate descriptors, which would help me prioritize which of these hits I'd like to focus on. In this case though, what I'm going to do is open a browser so that I can view these hits in the receptor environment together with a 2D schematic, one entry at a time. I'm just going to click to cycle through some of those. And here we find new molecules that fit in the binding pocket. They meet the Pharmacophore requirements in the sense that, as an example, we always find something hydrophobic or aromatic in this part of the pocket. We achieved this using Pharmacophore features that can be customized with the Boolean operators. So that brings us to the end of today's session. Today, we learned how to perform a Pharmacophore search to find new molecules that fit in a binding pocket whilst preserving key interactions. I hope you've learned a lot today. If you have any questions, please do reach out to me at support@chemcomp.com.